Okay, in today's lesson, we're going to talk about two-step equations. We have two-step equations on page 53, and Monday's date is 9/25 of 17. When you get that written in, please turn to page 53 or maybe your next page in your journal. And we will start with two-step equations as our title. Okay. The first thing we want to discuss for two-step equations is how it's modeled. So modeling two-step equations. All right, so the biggest thing with modeling two-step equations is when you have a variable in it, they typically do, well, almost all the time, a long rectangle. And this stands for your variable. Okay, and then your single squares are for your numbers. And that's usually how they're modeled. You can have a positive or negative variable. You could have a positive or negative numbers. And so they typically are colored or at least determined with a positive or a negative. So we're going to go ahead and do at least one example like that. So let's go ahead and just dive into an example. All right. What if I have 3x minus 4 equals 5? I want to represent that as a model, or using our variables and our numbers with these boxes or rectangles. Okay, so this is a positive 3x. So the rectangles can either go sideways or up and down. It doesn't matter. But we're going to go ahead and do sideways to save some space. And so I have 3 of those. And a lot of times they either mark them as the actual variable. They could put a plus sign in there, meaning those are positives. Okay. And then for here, I have a negative or a subtraction of 4. Okay. So I'm going to go ahead and put in some negative 4 boxes. And so our number is represented by an actual square. And I have 4 of those. Okay. And we're going to identify those as negatives. Then it is equal to positive 5. Okay, so then I need 5 squares. Okay, we're going to mark those as positives. We'll go ahead and mark these as positive x's. Okay, just so that everything is on the same page. Now, typically this is represented in a big box like so. Okay, so this line in the box is going to be your equal sign. So everything to the left of the equal sign is represented in one box. Everything to the right of the equal sign is represented in to the right in the box, okay, of the equal sign. All right. Now to solve for this, you have to solve for the x. You're looking to get the x by itself. And we'll discuss that in the next piece. But we wanted to see how it's modeled. So your variables are long rectangles. They could be on its side. They could also be up and down, like so. Okay, variables like so, up and down, rectangle, or side to side. Your numbers will always be represented with a square, whether positive or negative, like in this model. And this is modeling a two-step equation. Okay, so now we're going to actually solve for this. So this is the model, and we're just going to go ahead and solve for this two-step equation. So 3x minus 4 equals 5. From Friday's lesson, we talked about the one-step equations. we started off with adding or subtracting. So we're going to start first with the adding or subtracting of our two-step equation to get your variable by itself. So the key to this is to get variable by itself. Okay, the variable would be x. All right, we want to get x by itself. Variable by itself. All right, in order to do that, we are looking at this subtraction of 4. Remember from Friday's lesson, I said we have to take the opposite or do the opposite to both sides of the equals bar. Okay, so a -4 or a subtraction of 4, we're going to add 4 to both sides. Okay, when you have the same number of negatives and positives, those are zero pairs. So those are now gone. And what's left on this side right now is a 3x equals, and then 5 plus 4 is 9. Okay, 3x is 3 times x. So the opposite of multiplication is division. So we would divide by 3 on both sides of the equation. Okay, 3 divided by 3 gives you your 1. So you're left over with the 1x. Put it here, equals, and then 9 divided by 3 is 3. Okay, so x equals 3. And again, we are trying to get the x by itself. And when we do the 3 divided by 3, that gives us the 1 whole x. And when you're writing 1x, you do not have to put 1 in front of it. X alone represents 1x. Okay? In order to check to see if I did all of my subtracting, adding, multiplying, and dividing correctly, this says that x equals 3. So we're going to plug in, okay, 3 for x. So we're going to plug it in to check. Plug it in. All right. So now we have our original equation 3. Our x is now 3 minus 4, and it should equal 5. 3, order of operations, you do the multiplying before subtraction. So 3 times 3 is 9. Everything else comes down. And then 9 minus 4 is 5. And both sides are equal. Now, the last thing you would do sometimes with this type of problem is representing it on a number line. So let's go ahead and put a number line down at the bottom. Okay, 0, 1, 2, 3, 4. Let's go ahead and put a negative over here so because we know it goes both directions. So this is representing on a number line. Okay, and the value of x is 3. So we're going to just simply put a dot at 3 because that is what it equals. And this will the number line will become more important whenever we start looking at inequalities here later on this week. All right, so we're going to do one more example for clarity. And so we're going to go through all the steps of modeling, solving, and representing it on a number line. 3 steps to it. Okay, so let's go ahead and take 2x plus 1 equals 9. 2x plus 1 equals 9. All right, so we're going to start off with our modeling. So we're going to model here. And we have 2 x's, so 2 variables. And I'm going to go ahead and do this a different way that you could possibly see it, with the x being standing tall rectangles. Okay, and then we have positive here, positive 1, and this equals 9. So we need 9 squares. and all of those are positive. Okay, draw our box around it where our equals go, just like so. All right, so on the left-hand side of the equal sign, we have 2x represented plus the 1. On the right-hand side of the equal sign, we have our 9 positives. Now let's go ahead and solve for this. So now we're going to solve for x, or solve for the variable. So we have the 2x plus 1 equals 9. The first step, we remember, is the important is getting your variable by itself. That is the key to all of the equations with a variable in it. So we're getting our variable by itself. We're going to go ahead and then the opposite of an addition of 1 is a subtraction of 1 on both sides. Okay, this becomes a 0 pair, so that all that's left over on the left-hand side is your 2x equals 9 minus 1 is 8. Okay, this is our new equation, which is 2x equals 8. This is your two-step equation. This becomes a one-step equation. Okay, so in order to get 2 to the other side so that we can get x by itself, 2 times x, the opposite is division. A division of 2 on both sides gives 2 divided by 2 a 1. So now I have 1x by itself, and 8 divided by 2 is 4. Okay, we want to plug in to check. So plug it in to check. And so in our equation 2, and then the x we said is 4. So 2 times 4 plus 1 should equal 9. Order of operations, multiplication first. 2 times 4 is 8. Okay, everything else comes down. 8 plus 1 is 9. And 9 equals 9. Okay, we want to represent this on a number line. So we take and draw a number line at the bottom. Making our number line. And we said that 4 or x equals 4. So on our number line, we want to put a closed dot at 4 because that's what's representing x equals 4. Okay, in class we will talk about writing two-step equations. And we'll leave that for class because it's a lot about what the words are and what the problems are asking us to do. So make sure you have how to solve for two-step equations in the modeling. And then tomorrow in class, we will talk about how to write a two-step equation from a word problem so that we can solve like the examples before. All right, see y'all tomorrow in class.